Earth, a tiny speck of dust orbiting a run-of-the-mill star, the outer bands of a typical spiral galaxy. A story 4.5 billion years in the making, or so those God-hating atheist scientists would have us believe. But a recent publication in one of the most prestigious scientific peer-reviewed journals is about to change all of that. I wonder why a bunch of God-hating atheist scientists, reviewers, and editors would publish such a paper. Weird. 4.5 billion years. It's a very long time. Surely no one was around back then, so how exactly do scientists know how old the Earth is? Over the past century, radiometric dating has become one of the most powerful dating methods. This technique relies on two key assumptions, one of which is about to fall. Well, sort of. But before we get into what the specifics of these scientists have to say, I want to take a step back and go over exactly what radiometric dating is. Radiometric dating works on the following principle. Over time, radioactive material will decay. The starting material is known as the parent element. What it decays into is known as the daughter element. If one knows the rate at which the element decays, how much parent material there was to start with, by measuring the amount of parent and daughter material present today, one can back calculate how old the rock is. But this technique relies on two key assumptions. The first is that the rate of decay for a specific element has been constant over the lifetime of the rock. In the case of the oldest rocks on Earth and asteroids in space, we're talking billions of years. Clearly, since no one was around for all that time, this is a reckless assumption, put in place by God-hating atheist scientists to disprove the literal interpretation of the Bible. Not really. First, scientists have subjected radioactive elements to a wide range of temperatures, pressures, magnetic and electric fields, without measuring any change in the rate of decay. If it were possible to accelerate the rate of decay, we wouldn't have radioactive waste piling up for nuclear reactors. Second, the rate of decay was faster in the past as suggested by some creationists. This doesn't bode well for the Earth. See, as radioactive elements decay, some of their energy is given off in the form of heat. Even small amounts of radioactive material can produce an enormous amount of heat. It's the principle by which our nuclear reactors and weapons work. Well, if you accelerate the rate of decay, you accelerate the rate of heat production. The core of the Earth is kept molten in part due to the heat given off from the decay of radioactive elements. If you compressed 4.5 billion years of radioactive decay into a few thousand years, as some young Earth creationists would have you believe, the ground you're currently standing on would be molten. Yet that doesn't seem to be the case. Everything we know about the nucleus of the atom collected over the past century has told us that the rate of decay of radioactive elements has been constant for billions of years. The second key assumption in radiometric dating is that you can somehow know the amount of starting material. For example, one of the major techniques used to date the solar system is the uranium-lead technique. Uranium, produced in a supernova, whose remnants seeded a gas cloud which gave rise to our solar system, decays into lead at a known rate. Uranium-235 decays into lead-207, uranium-238 decays into lead-206. However, all the isotopes of lead were also produced in the supernova. Therefore, when scientists want to determine the age of a meteorite, they can measure the amount of lead and uranium in it, but some of that lead was there from the beginning, with only a fraction being derived from the decay of uranium. Knowing exactly how much is paramount to getting an accurate date. Clearly, those scientists must be making up numbers to fit their agenda. How else could they know? They weren't there. Well, actually, a moment of careful thought will lead you to the answer. How can you determine how much primordial lead there was in the early solar system? Simple. Find a meteorite that contains lead but no uranium. Every such meteorite has exactly the same ratio of lead isotopes. For example, there are 15 parts lead-204 for every 985 parts lead-207, and lead-204 is not the product of any decay process. Therefore, if you measure the amount of lead-204 in your meteorite of choice, you can calculate how much of the other lead isotopes are primordial, the remainder being the product of radioactive decay. But this only gets us part of the way there. We actually have two decay processes, uranium-235 and uranium-238. Therefore, we need to know the individual amounts of these starting elements. And here's where the trouble starts. For the past few decades, scientists have relied on the assumption that the isotopes of uranium would be equivalently dispersed throughout the early solar system, as there are no chemical processes that can lead to any significant fractionation of the isotopes. I know, how silly could they be? Therefore, once they determine the ratio of uranium isotopes in a few samples, which is 137.88 parts uranium-238 to every 1 part uranium-235, due to the extreme difficulty of the technique, they simply assumed this ratio in all future samples. But now a group of scientists have come forward arguing that this assumption is wrong. The reasoning behind the assumption is still valid. However, until this paper, no one took into account the element curium-247. Curium-247, it turns out, can decay into uranium-235. Therefore, while uranium isotopes would have been distributed equivalently throughout the early solar system, curium could have been distributed completely differently. Anywhere that curium-247 was in high concentration, today we would see an enrichment of uranium-235. Clearly, radiometric dating is flawed. The entire technique should be thrown out, and we should simply rely on the Bible to tell us the Earth is 6,000 years old. No. The simple fix is to measure the ratio of uranium-235 and uranium-238 in each sample. With modern technology, this has become easier. In doing so, this group showed the actual ratio of these two isotopes can vary as low as 137.41 and as high as 137.88, meaning the solar system is not 4.55 billion years old, actually closer to 4.545 billion years old. So when someone says radiometric dating is inaccurate, yes, it's 0.1% inaccurate. Radiometric dating is actually a collection of over a dozen independently verifiable techniques, each with their own strengths and weaknesses. Potassium-Argon dating is useful to determine when igneous rock solidified. Potassium decays into argon gas, which can diffuse out of liquid rock. Once the rock solidifies, all newly produced argon will be trapped, starting the clock. However, if the rock is reheated, any trapped argon can be released, resetting the clock. Scientists know this and will not use this technique on rock that shows evidence of reheating. Carbon-14 dating can be used to determine when organic material was last alive. Carbon dioxide containing a C14 atom is taken up and incorporated into plants. The amount of C14 in the plant is in equilibrium with C14 in the atmosphere. How do we know how much C14 was in the atmosphere in the past? We calibrate it using trees. How do we know how old the trees are? Simple. We count the rings. Once the plant dies, incorporation stops, starting the clock. This technique only works for organisms that are closely tied to atmospheric carbon, such as plants, herbivores, and carnivores that eat herbivores. But deep-sea organisms feeding on carbon that has long since been in the atmosphere will give horribly inaccurate dates. Also, nitrogen-14 that is in close proximity to uranium can be converted into C14. Ever heard of scientists finding C14 in coal? If coal is millions of years old, all the carbon-14 should have decayed away, due to it having a half-life of only 5,700 years. Is this proof coal is actually very young? No. Carbon-14 is only found in coal with high concentrations of uranium. And finally, each radiometric dating technique has an age range within which it's most accurate. The sample must be old enough for some daughter material to be produced, but not so old that all the parent material has decayed away. The sample doesn't have both parent and daughter material in it. You can't use radiometric dating. Ever heard of scientists using radiometric dating on the 1980 eruption of Mount Saint Helens, where they got ages on the order of hundreds of thousands of years? This was a perfect example of the misuse of the technique. To call radiometric dating flawed is like calling a bicycle a flawed means of transportation simply because you can't ride it to the moon, or a fork a flawed utensil because you can't use it to eat soup. Each technique has its strengths and weaknesses, and scientists know these. Who do you think discovered and published them? When used appropriately, they all yield highly accurate and consistent results. The solar system is 4.55 billion years old, give or take a few million years. Scientists will continue to refine their techniques and overturn old ideas, an ongoing effort to better our understanding of the universe. Creationists will continue to lie and mislead in an effort to drag society back into the dark ages of dogmatic and theocratic rule. But you are still free to.